So Logan placed $4,000 in an account that earned 7% annual interest compounded quarterly. Okay. So it says, what is the value of the account for each amount of time shown below? Show your equation and your answer. So if we have 7% annual interest and that's being compounded quarterly, that means every single quarter the interest rate is going to be 0.07 divided by the number 4, right? 0.07 divided by 4. And if I look at that, that is 0.035. No. I divided that by 2. That's not what that is. That is going to be divided by 4. That means that each quarter, right, is 0.0175. So each quarter it's going to go up by about 1.75%, right? So 1.75%. So I can write that as a percent. It's 1.75 is the quarterly amount. Now, if it's going to grow by 1.75%, the multiplier for each one of those periods would be 1.0175. So that's my multiplier for each quarter. So my equation is going to look something like this. If y is the amount of money, right, I've got an initial deposit of $4,000 times 1.07 to the x power. Now, the important thing to recognize here is that x, right, x is quarters, Quarters. So if I want to know what the account is worth in 5 years, that 5 years is 5 times 4, it's 20 quarters. And that just means a fourth of a year, not 20 quarters that you would put in a vending machine. Quarters are, it's compounded quarterly, so each year has 4 quarters. So there's 4 compounding periods. That's why I divided this by 4, because it was quarterly, not monthly. So there's a 4 there. Okay, so the answer to the question then, for 5 years, right, what do I do? Well, let's grab our on-screen calculator, friend. Let's see, calculator, there we go. And I'll take and turn you on, turn it on. Oops. So I get 4,000 is my initial deposit times 1.0175 raised to the 20th power. And the reason why it's 20 is because it's 4 quarters, right? So to the 20th power. And I get that in 5 years, the balance should be $5,659 and just 11 cents. Okay, so this is my answer for A. And then the other kind of awkward question is like, what would the account be worth 2 years ago? Well, that's difficult to say because I didn't deposit it 2 years ago. I deposited it now. But I could play this game and I could say, well, 2 years ago would be minus 2 times 4, so minus 8 quarters. So I could do this. I could say, if I wanted to, I could plug that number in for x. Right? I could plug in this negative 8 for x and see what it gives me. So let's go back up here and grab it. Whoops, there it is. Got it. And I'm just going to come up here and I'm going to delete that 20 and just enter negative 8. And when I enter negative 8, it gives me, okay, it would be worth $3,481.65. Okay, and that is for B. That's for 2 years ago. Now, just kind of as a satisfying my curiosity here, I've got that value, and if I on my calculator say I'm going to multiply times 1.0 175. If I do that 8 times, it should put me back at $4,000. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. Great. And I could run this out 20 quarters too, and see if I got the right answer. So it's like, do you not believe in exponentiation? You could just use exponents. I know. I'm just trying to like think about this multiple ways and see if I'm correct. So I'm going to multiply this by 20 more quarters and see if I get to the $5,659. So I'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Halfway there. 1, 2, 3, 4, 5. 5 more. 1, 2, 3, 4, 5. Well, what do you know, huh? The beauty of exponents. I can raise it to that power of 20 and it gives me the exact same thing. So yeah, 5 years in the future, at 7% annual compounded quarterly, we should have $5,659. And if somehow we could go back in time, having made the investment at a previous date, originally it would have been worth $3,481.65. If 2 years ago, right? That's it.